Okay. Then we can start, huh?
Okay, no
Yeah.
problem. Yeah. Uh, now he's here now.
All right.
Uh,
Minute, please. Okay. This is the document.
yeah.
Yeah. For our this thing, how to call it? Our assignment, huh?
Yeah. Project.
You remember discrete mathematics.
Yeah.
Okay. Um, for records,
Yeah.
this a group. This our group. I Abubakar Isise and Umar Fofana.
Yeah.
And Ibrahim Adrame. Good. Um, as the lecturer has ordered, he says we take one of the a journal paper which is related to our course. Then we write a summary about it, a review about a review summary about it. So the paper we took is this.
Yeah. Free bus.
Why is my this thing not working? Okay. I hope you guys are seeing, right? The paper.
Yeah. 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 We
Oh,
say.
okay, thank you very much. So the journal identity, the parts he said we should talk about is the journal identity, the summary of the journal. There's number two, citation, as you can see, critical analysis to analyze the document critically. So,
Yeah.
and fourth, relevant to course materials. It should be relevant to our course, which is discrete mathematics. Fifth,
Yes.
suggestion for further studies and conclusion and reference. Huh?
Yeah.
Thank you very much. So the journal, the main journal is titled Constructing Tree-Based Index for Efficient and Effective Dense Retrieval.
Yeah.
When we say dense retrieval, like let's assume like you to search a document on from this thing, how to call it, from a search engine like Google or
Go.
even
Go.
ChatGPT and the likes. You know, you have thousands or millions or let's say billions of documents there.
Yeah. Yeah.
Okay, so to search in them, this
Yeah.
research document is specifically about that, using machine learning or AI in order to search document with based on this thing, tree based index.
Index.
To be honest, that is the this thing they are using.
Yeah.
Okay,
Summary.
the authors, there are many authors. They are all Chinese guys. I to pronounce their names is just this thing, how to call it.
Yeah.
Mm,
Very cool. Chang.
Yeah,
Chang. Fun.
yeah. I hope you can see that. I don't know whether you guys
Yeah.
can
Yeah.
pronounce it.
Xin Yo. Zhang. Yi. Yi Gun. Liu. Fan. Zhang.
It's funny, huh?
Yeah. Yeah.
That's it. That's it. That's it. It's funny. Yeah. So the journal was published July 2023. That was the
2023.
published year of the journal.
Mhm.
So like here you have 2023. It was 2020 July. I think 7th July, if I could remember very well. It was 7th July 2023.
Oh,
Yeah.
ini very bagus.
So
Eh,
journal the journal, it says proceedings of the 46th International ACM um,
mhm.
SIGIR conference. So the journal was listening at this conference, ACM SIGRI conference. It was the
Yeah.
46th conference, their 46th conference.
Yeah.
Yeah.
DOL. Okay.
So as I was saying, like
Yeah.
this thing. So this is the link to the journal. You can see. Let's click it and see.
This, yeah. The journal. Okay.
This is the main document.
The original one. Right.
Yeah. The original document itself.
Yes.
You can see, so it is
Yeah.
constructing tree-based index for efficient and effective dense retrieval. So like here,
Tiba.
these guys are the authors. 1, 2, 3, 4, 5, 6, 7. It's a joint this thing research publication.
I see.
Let's see some. It says here, recent studies have shown that dense retrieval techniques can significantly improve the performance of first stage retrieval in IR system. So like I
Oh,
would say in dense retrieval, like in computers, we don't search with
yeah.
words. Like searching are not done with words. You know, computers don't understand words; they understand numbers, like
Oh,
binary numbers. We use numbers.
yes. Yeah.
Every document or question or queries get turned into a long list of numbers called vectors.
Vectors.
Yeah, vectors. The documents are numbered, series of numbers, a long list of numbers, and it is called vectors. They are called vectors. So this is what is called a dense retrieval. I hope you understand.
Yeah. I understand.
Thank you very much.
Yes.
So
Yeah.
they are using this thing, how to call it, like in the this thing here, how to call it, like tree base index. Like when we say tree, just think of like the real tree, the real tree. I hope you understand, huh?
Yeah. Yeah.
You know,
Yeah.
tree,
Yeah.
you have like the stem, you have branches, main branches and small branches and leaves, right?
And leaves. Yeah.
Thank you very much. You can see an example here. Let me show you. Like here, this it says
Yeah.
figure one illustration of the joint retrieval joint. I don't know this one. I forgot the T what it stands for. It's a JTR tree structure.
Right.
The integer represents the sequence numbers of the node. In this case,
Yeah.
the tree has a depth of 3, number of clusters
Numbers.
4, branch balance factor beta equals to 2, and the leaf balance factor equals to 4 is 4, right? So here you can see this is the main stem, and you have the
Yeah.
branches here, the main four main branches, and these are the
Branches.
clusters, the cluster nodes, and
Okay.
these are the cluster assignments. This is where
Yeah.
you can
Yeah.
see it says root nodes. That is this one, the main stem, and intermediary nodes, which are these ones, the green colors, and these ones
Yeah.
here
Yeah.
under, they are the this thing, how to call it, documents themselves, like the cluster
Documents themselves.
assignments.
Yeah.
I hope you understand, huh?
I understand. Understand.
Let's say like when you are searching for documents, some documents, you have um all the documents, that is the main branch here, all the documents are here. Example, like, so you divide them into smaller groups, force into two groups, like let's say two groups as in the tree here. So from there you have the next smaller branches, which are these ones, and you have
Yeah.
the leaves, which are the actual documents themselves, into clusters.
Yeah.
Yeah. So we can go back to our document and see.
Document. Yeah.
Yeah. So here it says summary of the journal. Dense
Yeah.
retrieval system representing modern standard in high performance information retrieval.
Yeah.
Where queries, when we say queries are like questions, sentences, and the likes. Yeah, queries and documents are encoded into high dimensional dense vectors using deep learning models. This approach, while powerful, introduces significant challenges in terms of scalability and efficiency.
Yeah.
Traditional brute force methods like FAISIS requires exhaustive comparison with all vectors in the database, leading to high latency.
Latency.
Yeah.
The journalist introduced. Yeah.
Come again, brother.
I know. I was just reading the test. The
You wanna
journalist test.
ask a question? I hope, or
I just was reading it.
the meaning of what?
Continue.
Latency, right?
Yeah.
Yeah, it's a waiting period. It's a waiting time, like waiting time. Like example, like when you put a query in the system and waiting for the
Yeah.
and waiting for the time that the computer takes to
Yeah.
process your query to
Yeah.
give you back the result. That time that you wait for, it could be like seconds, like 1 second, 2 seconds, or 3 seconds, something like that. That waiting
Yeah.
period is called latency.
Latency.
Yeah,
Okay. Okay.
yeah.
Yeah.
So
Understand.
we can proceed, right?
Can.
Shall we proceed?
Yeah. Yeah. Let's.
Okay. The journal introduces a novel solution through a hierarchical tree base, like the one hierarchical tree base, like the one we just see in the main document there, right?
Yeah. Yeah. Yeah.
Okay. So hierarchical tree based structures called hierarchical clustering tree.
Yeah.
The
Yeah.
approach clustering is meaning grouping.
Grouping.
Yeah, grouping. Yeah,
Okay. Okay.
you get it, right?
Yeah. Yeah. Get it.
Thank you very much. So it says the approach uses recursive k-means clustering to build a multi-level tree of document embedding. So when we say k-means,
Yeah.
k-means is a clustering algorithm. It takes a bunch of
Yeah.
data. Yeah, it takes a bunch of data and groups them into clusters. It's an algorithm.
Mm.
So like
Yeah. Yeah.
it takes many data, like a bunch of data, many data, a large amount of data, yeah, and group them into clusters.
Yes.
Yeah, based on
Okay.
how they are similar to each other, based on similarities.
Covered.
Yeah.
Okay.
So basically, clustering means organizing a data into groups. Cluster.
Yeah. Yeah.
Cluster. Yeah. You get the point, right?
Yeah. We get it. I get it.
Okay.
Yeah.
So at query time, the
Yeah.
search is narrowed down to the most relevant part through top-down traversal, significant reducing the number of distant computations.
Yeah.
Experimental result on data set like MS Macro, Mako, and
Yeah.
TrickDL shows that HCT achieves retrieval speed up to 10 times faster than the traditional baseline. Like traditionally, the way we used to retrieve data, traditionally,
Yeah.
in like when you are searching in this thing, how to call it, Google search engine or the likes, the way we used to search it, this one is faster than using this method is faster, far more faster, like 10 times faster than the traditional one.
Okay. Okay. Yeah.
With comparable and improved accuracy, the proposal method blends retrieval effectiveness and computational efficiency, providing a scalable solution for real tree
Really.
applications such as search engines and recommender systems.
System.
Yep.
Okay. Crucial analysis.
So like if you would like to distinguish, I can pose. You can give an explanation. You can give a presentation on the other the remaining ones. Then Ibrahim also can try.
Okay.
So that we can all participate. Or that's if you mind.
Yeah. Let's just read it. Crucial analysis. You hear me?
Yeah, I'm hearing you. Yeah, very well. Yeah.
Okay. Okay, so I will read it, right?
Huh?
I will the crucial analysis.
Yeah.
Critical analysis.
Mm-hmm.
This paper offers substantial technical innovation in applying discrete structures to dense vector indexing by relying on recursive clustering and what you push it up. Can push it up.
Hmm?
Pu- the document. Scroll it up.
I scroll right.
Yeah. Yeah. Okay.
Is it fine?
Yeah, it's fine.
Thank you very much, bro.
The Holocaust model, the authors bridge the gap between theoretical. What the meaning of this?
Which one is that?
Between theoretical computer science and applied AI system.
Theoretical, right?
Yeah.
The gap between theoretical computer
Yeah.
science and applied AI systems.
AI system. Yeah.
Yeah.
Yeah. What the meaning of critical? This theoretical.
Theoretical,
Yeah.
like theory. Theory is this thing like concept, like the knowledge itself,
Uh,
but not the application.
uh,
Yeah, like the knowledge of something.
okay. Okay. Yeah.
Yeah, the
Okay.
idea, the concept.
The concept.
Yeah, the
Yeah.
concept.
Okay.
So the practical is called the application.
Yeah.
Yeah.
Okay. Yeah. Okay. Let's go to continue to strength.
So now here, like here, theoretical computer science is the theory,
Yeah.
is the idea, the knowledge. Do you understand? So the application
Yeah.
is applied AI systems. That's the application, the
Okay.
practical application. Yeah.
Okay.
Yeah.
Okay. Strengths. Okay. Let's go to the strength. Strength view creative use of tree theory for district mathematics in advanced machine learning system. Okay. Significant improvement in both speed and scalability of retrieval systems. Okay. Strong empirical validation across multiple data sets and configurations. The strength he's talking about, like especially this what
Come again?
the strengths.
Yeah.
This fact, yeah,
The strengths are the advantages, the benefits.
are the benefits of
Yeah. The advantages.
like,
Yeah.
okay. And now weakness,
That is the weaknesses.
weaknesses,
Yeah.
for the topic, right?
Yeah. For this system, like this technology.
Okay, the weaknesses.
Yeah,
Okay, okay,
yeah.
okay. Construction of tree index can be computationally expensive.
Mhm.
Okay, 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 expensive. Yeah. Effectives may declare for if the embedding this is embedding
Come
this
again?
this if the embedding
What? Embedding.
yeah embedding
Yeah.
embedding that's mean to be low or to
Come again?
to embedding the meaning of embedding it's like to collect
You say it's like what?
it's like to collect something to embed
No. This thing, how to call
Meaning,
it?
kilo waju menya megwe.
uh,
An embedding
yeah
is a way to turn words,
yeah
sentences, or documents into numbers
yeah
so that computers can understand their meaning and do maths on them.
yeah
I
understand
hope you understand. So like
yeah understand
as we said earlier, computers don't understand words and the like. So it is going to be converted into normally in normal case it's binary numbers. Do you understand?
yeah
Yeah. So that's what computers understand and they will compute it. Compute means calculate it like do mathematics on them.
okay
Yeah.
I understand. Okay. The third step, the method relies on well-turned hyperparameters, e.g., branching factor. Okay, which may require training for difficult datasets. Now, yeah. Okay, scroll it up. Yeah. The approach utilizes fundamental tree concepts such as roots and depth, height, and travel style. Travel style, like machine machines in this context. In this context, parallel parallel based first on Grady search technique and guide by similarly metrics in the vector space. The use of clustering algorithm to form the tree also tie into combinatorial combinatorial optimization and algorithm partitioning key area in district math. Industry ما يستخدم منهج okay ترجمتها لكي أفهم
Yeah. Hmm?
يا يا قلت ترجمتها لكي أفهم جيدا I translated to understand well yeah okay
Okay.
yeah we'll continue
Yep.
relevant to course material okay the paper integrates several core topics from district mathematics, including tree structures, first tree structure, and what is it? Hierarchical. This is what
Hierarchical modeling.
hierarchical.
Yeah.
Hierarchical model. The hash CT is a classic example of root tree with hierarchical parent child relationships. Okay. graph and network theory. The embedding spaces is implicitly right, treated as a high dimensional similarity graph. Recurve recursive algorithm. Key means clustering is recursively applied to form subtree algorithm complexity. HashCT reduces search complexity from linear and to algorithm in practical term aligning with a site what if a cytotic analyzes stuff in the course. This makes the study not just relevant but an ideal application of the theoretical foundations with covered in district mathematics. Okay. Oh. Suggestion for
Come again?
Scroll it up.
I scroll, right?
Yeah.
Yeah. So like before we scroll, like here, number 4,
Yeah.
relevant to course material. Here, the concept here is like the relevance, the relationship between the this thing, how to call it, this research document, this journal according to our course, which is discrete mathematics. Like
Yes.
when you read the document itself, you will find out that there are many topics which we studied in discrete mathematics are dealt in the document, fundamentally dealt in the document. Yeah, I hope you understand. Like parent-child relationships. We did that. I think is it session 14 or session 15, something like that. In 3. Graph and network theory also the same thing applies. You get the point, right? Hello, is your connection good? It seems like your connection is a bit bad. Then I will continue from here. Or whether hello,
Hello,
Ibrahim.
no,
Omar, his connection is bad, right?
I think.
Yeah. Okay, then we can just continue from here. Number 5 is suggestions for further study. Future studies could explore dynamic update strategies for HCT to accommodate real-time indexing, which is current model does, which the current model does not address. Another promising direction is the integration of graph neutral networks with tree-based retrieval structure, blending representation with learning with discrete data structures. Students could replicate the HCT indexing model using Python libraries such as scikit-learn for k-means and NumPy and stimulate query traversal to better understand search complexity and path viewing. So that's it, and this is the conclusion. I hope, Ibrahim, you can present the conclusion.
Okay.
Yep, if you don't mind.
Okay. 6. Conclusion. This journal demonstrates the high impacts of discrete structure in real-world AI system by transforming document embedding into a hierarchical tree structure. The authors show how a class data structure, the tree, can enhance modern the retrieval system. The paper is a strong example of the practical use of discrete mathematics in solving contain a dig information, processing problem, and encourage put the exploration of the intersection between theory and application.
Very good.
7.
Yeah.
Reference. Zhang X, Li, Y, Zhang F,
So,
E, L, 2023. Constricting tree bus index for efficient and effective dense retrieval proceeding of the 46 International ESM Singing Conference. Yeah.
Very well. That's awesome. That's very great. Yeah. So that is the this thing, how to call it, the document, and I hope very soon our time is going to end. Omar, you said what? I think Omar want to speak.
Omar.
Okay. I have been logged out automatically. I don't know why.
Okay. Okay. Yeah. Basically, this is the end of the this thing, how to call it, the presentation.
Journal.
Yeah. So
Yeah.
I hope you guys have recorded it, right?
I didn't record it.
You did not record it, huh?
I know I didn't.
Okay, I was doing the recording here, so
Okay.
let me try
Yeah.
and see if we can distinguish how to call it.
So we'll just send the link of the recording.
Yeah, the recording. Yeah, yeah,
Okay.
that's fine. Yeah, we can use the link. Yeah, but with the this
Yeah,
thing,
yeah.
how to call it? With the this thing, um, with this thing.
Alright.
With the file, the document itself. I think I shared the document with you guys. Yeah.
Yeah. Okay.
Yes.
Okay.
So that's it.
Okay. When you make the link, you can send it again. So,
Okay. Okay.
yeah.
Thank you very much. Yeah.
For this Nugraha.
Yeah. Let's stop. Let me stop this first, and after we can talk about that.
Okay.
Yeah.